now we're going to move into a function type that is a little different than any other that you're going to see, but it's the one that probably represents real life scenarios as well as anything. And these are called piecewise functions. Now, simply piecewise functions are a single function that are made up of pieces of other functions. So if we look here, our very first function equation f of x equals, and then we have this little bracket looking thing. And we have two separate lines. We have 2x minus 1 and we have 3x plus 1. And so we have a function that's being made up of two separate lines. But we can't draw both lines and completely across the graph to represent the piecewise function, because then it wouldn't pass the vertical line test. So we have to draw pieces of each of them. And the piece that we are going to graph is going to be based off of this condition that is given to us. And this condition is given to us in an interval form. So it says here that we're going to graph 2x minus 1 for all of the x values that are smaller than or equal to 1. And then we're going to graph 3x plus 1 for all the x values that are bigger than 1. And so what we're going to have there are actually two separate pieces to the function, and that's why we give it the term piecewise functions. Now, we'll get to the graphing part of this in a later video. What we're going to start with, however, is with evaluation. And if you remember, evaluation just simply means to substitute a value in to the function. Now, basically when you evaluate, that's just like having a glorified t-chart. And so basically you can see here in part A, example 1, we're going to have an evaluation for x equals to 0, b equals x equals to 2, and c x equals to 4. So technically what you're simply doing here is getting a t-chart when you have these given values. And so nothing more than that. And so you're going to plug in those values for x. However, the key here is this. Depending upon the value of x that we're plugging in will be determined which function piece we're actually going to evaluate. And so let's take a look at part A. If you look at part A, it says that we're going to evaluate 0. Well, 0 is less than 2. Since 0 is less than 2, that's going to have us evaluating this first part of the function. So we will only evaluate that part of the function and not both of them, because it doesn't fit the condition of x is greater than 2. So if we plug 0 in for the first line, we're going to get a value of 2, and so you can see that's the point 0, 2. Now if we go to B, x is equal to 2, we have to find the one where it makes a true statement. So if you say 2 is less than 2, that's not true, but 2 is greater than or equal to 2 makes that a true statement. So we're actually going to use the second piece of this function for part B. And so we plug 2 in to 2x plus 1, and you can see we get a result of 5. And then lastly we have 4. 4 is also greater than 2. And so we're going to use that second piece again, and we end up with a value of 9. And so basically what we've created are 3 points that are on this graph. Now, that's just to kind of give you an idea, to remind you what evaluating a function is all about. The key here is that you're doing nothing different than you did in the first unit, except that you have to pick the right piece based off the condition that's given to you. So let's go ahead and try this on your own. Evaluate a sample problem number 1. You have 3 parts. Make sure you plug the x value into the condition first to see that it creates a true statement. And then when it does, you go ahead and evaluate that part alone. So pause the video now and try these 3 samples. Okay, so hopefully you've done that. And we're going to do part A. X equals to 0. You can see here that 0 is less than or equal to 3, so that means we're going to evaluate 0 for the very first piece. So I'm going to say f of 0 equals 3 times 0 plus 2. Very important that you put f of 0 and not f of x. F of x represents the whole thing. F of 0 only represents this little piece. And then, of course, f of 0 equals to 2 itself. And so that would be your final answer. We are not solving for f here. You could also write this as an ordered pair if you like. So 0 in this case was the x, and our output value was 2, so that's also an appropriate way to form your answer. Okay, for part B, we actually have 3, and so we need to find the one that is equal to 3. So 3 is less than or equal to 3, which is a true statement. So that means we're going to evaluate 3 for the first piece again. And f of 3 is going to equal to 11. And last but not least, we're going to evaluate f of x for x equals to 6. And so you can see here we want to pick the piece that 6 is greater than 3. That makes a true statement. So we're going to evaluate f of 6 for the for the second part, or the second piece, and f of 6 equals to 5. So that is just your first example of dealing with a piecewise function. We were basically just evaluating like we did in Unit 1, and now we just have to pick the appropriate piece.